Welcome back, learning here with me at MPB. I'm Ms. Killen. We are still in Unit 4 working with these functions. Now we're in Lesson 7 where we are looking at more key features to know. We're looking at IF4, I can determine by examining graph key features of a function. So let's just dive on into these vocabulary that we're going to need to know. All right, so some important vocabulary to learn is our domain. Now, we know domain as what? You're right. It's our x values. Good job. So then my range is going to be my y values. Good job. Now the new one that we may not be familiar with is set notation. Set notation looks like this. X such that x and then this symbol. What we need to know about this, and I want us to make sure that we are putting this in our notes page. This line right here means such that, and this symbol right here means elements of. And these will make a little bit more sense as we get into writing these set notations for different things, but I did want us to know what the set notation is. Now, an interval notation. My interval notation is going to have some type of grouping symbol. Depending on what's going on with the numbers or the interval, depends on what type of grouping symbol I use. So that's what my interval notation is. My next one that we need to put on those notes page is increasing intervals. Now when I have an increasing interval, this increasing interval, as my x values increase, my y values increase. That's why it's called an increasing interval. So then if I go to the next one where it says decreasing, what do you think that's going to? All right, maybe. But it is actually as my x values increase, my y values decrease. That's our decreasing interval. Now, what do you think about a positive interval? What do you think that positive interval could be? Maybe. But a positive interval is actually meaning my y values are greater than 0. Anything greater than 0 is what it means to have a positive interval. So then if I flip that, my negative interval is when my y's are less than 0. That's what my negative interval is. Now, we have heard the words minimum and maximum ever since. So if I have a relative maximum, that's going to be the top or the highest that I'm looking at. And obviously, my relative minimal is going to be the bottom or my lowest. So those are some very key vocab that we need to keep in mind as we go through this lesson, because we are going to see all of these in this lesson. So let's flip on in and see what we've got going. So our next slide looks like this. Let's use the absolute value function to answer some questions, all right? So this is what an absolute value function looks like. It's in the shape of a V. So it says, what could we define the domain as when using set notation? So let's look at this. My domain deals with my x's, x, 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 x. Now over here is going to be that negative infinity, and if I keep going, I'm going to get to my positive infinity. So I can say that all of my domain, or all of my x values, are really real numbers, from infinity numbers to positive infinity numbers. So they're all real numbers. So if I write that in a set notation, it looks something like this. Let's see. So x such that my x's are elements of that symbol. And if we don't know what that symbol means, it is all real numbers. So that mathematical sentence states x is such that x is elements of all real numbers. That's what that mathematical statement is saying about the domain of this graph. So the next one says, write the range of this function in interval notation. Now, the range is dealing with what values? Yes, my y's. So here are all my y's. So what can I say about this function with those y values? Yes, my function is above my origin. So that means that all of my y values are bigger than 0. So I could say that my range starts at 0 and it goes to positive infinity. Now you're sitting there going, Ms. Killen, why the two different grouping symbols? Good question. When I use a bracket of any sort, that means that whatever I'm talking about can equal. If I use a parentheses, it can't equal. I'm talking about usually a concept. It can go all the way to positive infinity, or it can go all the way to negative infinity. Or sometimes I'm using it in my inequalities and I can go right up to maybe the number 4, but never can get to the number 4. So I go right up to the concept of 4, but I never get there. Or I go right up to the concept of negative infinity, but I never get there. So when I use my brackets, it can equal it. When I use my parentheses, it can't equal. It can only go towards the concept. Those were some good questions. So let's look and see what else we got. More questions about the graph. So again, I have a absolute value graph, but now it says, does this graph have any increasing intervals? Now remember, my increasing intervals is when my y values get bigger and my x values are also getting bigger. So I would say this is where I have those increasing intervals. So how could I write that? Well, it starts at 0 and it goes where? Where does this stop at? It doesn't. It goes to positive infinity. So I'm using that bracket for 0 because it does equal 0, and then I'm using that parentheses for my concept of infinity. All right, let's look at the next one. Does this graph have a decreasing interval? So let's see. Does it have a decreasing interval? Well, for this to happen, as my x values increase, my y values what? They decrease. So my x values are getting bigger, getting bigger, getting bigger, but my y values are dropping, or getting smaller. So I could say that this interval starts at what? Negative infinity, because this is the negative infinity side, and it goes to 0. Using my parentheses for my concept, my bracket for exact. Good job. All right, so let's look at the last one. It says, is there a relative maximum or minimum? Well, in this graph, do I have a top that's the highest value, or do I have a bottom that's the lowest value? Yes, I have a low value. So I would say I have a relative minimum. Good job. That's really good using those key words to figure out the features of this graph. That was good work. Let's look at the quadratic function. Now, in our next couple of units, we're going to be using the quadratic function, but just to see these key features of graphs, I wanted to go ahead and introduce us to the quadratic. So it says, in set notation, what is the range of this graph? Now, we said that the range deals with what? My y values. So what can we say about this quadratic that my y values are? Yes. This is my negative infinity. This is my positive infinity. And if you can't draw the infinity symbol, that's okay, because sometimes I can't either. So let's do this in set notation. So the values of my y such that y is what? it's less than or what? Equal to 0. So all of my y's such that y is less than or equal to 0 because all of my y's are in the negative. Yes, good job. Now it says use interval notation for my domain. Now what does my domain deal with? You're right, my x values. Now Ms. Killen, why do you keep writing those above your words? Because I want us to make sure that we are understanding the concept of range. I want us to understand the concept of domain because as we get into more functions, we're going to have to make sure that we're understanding these words. So let's look at my domain. I'm starting, this is negative infinity, this is positive infinity. So what can I say about my domain? Now my graph just doesn't stop here. It keeps going on and on and on. I just had so much room on my slide. So where does it stop? It doesn't. So it's going to start at negative infinity and it's going to stop at positive infinity. Noting that I am using 2 parentheses to show those concepts. Remember, concepts, parentheses. I have an exact, I use those brackets. Good job. Let's look at the next one. Does this graph have an increasing or a decreasing interval? Well, let's look. Remember, increasing is where my x values are going up and my y values are going up. So do I have where my x values are increasing and my y values are increasing? Yes, right here. My y values are getting bigger and my x values are getting bigger. And so forth and so on. So I would say, yes, it is right here. And I would say from negative infinity to 0. Now, what about that decreasing? Where could we say that decreasing is? Remember, decreasing is when my x values are getting bigger, but my y values are getting smaller, or they're decreasing. So I can say that it's right here. So I'm starting at 0, and then I'm going to my positive infinity. Good job. Now let's look at this one. It says, what is the x and y-intercepts? Let's go to my y-intercept first. My y-intercept is where it crosses my y-axis. We've all known that. So where does this graph cross that y-axis? You're right, at the origin. It's at 0, 0. That's my x-intercepts. That's the coordinate for my, my y-intercept. That's the coordinate for my y-intercept. Now, what about that x-intercept? Ms. Killen, I don't see where it crosses the x-intercept. You don't see where it crosses, but you see where it touches. Where does it touch the x-axis? Same place. It touches my x-axis at 0, 0. Ms. Killen, are you saying that your x and your y-intercepts can be in the same place? Absolutely. Those x and y-intercepts can be in the same place. And we see an example of that. So don't be scared when you're looking for that x-intercept, okay? A lot of us have got that y-intercept down, but some of us are still coming to terms on that x-intercept. So don't be afraid to look, and it may sometimes be the exact same place. Good job. Is there a relative maximum or minimum in this graph? Do I have something high or something low? Yes, I have a maximum. This is my highest point in this graph. So I'm going to have a maximum. Good job. Now, let's do some practice. Help Leslie use this exponential function. Here's a new function that we're looking at to list the key features. All right, so the first thing is my range. My range dealing with what? My y values. Now, what do I notice about this exponential function? Yes, it never goes past this x-axis. So that means that all of my y's, such that y is going to be put the wrong symbol, y such that y is greater than or equal to 0. So those are my y, or my range. Now let's look at the domain. What do I notice about my domains? Now my domains deal with the x, and you see it has the arrow, so that means it goes on forever and ever and ever and ever. So that means it would start where? At negative infinity, and you see it going up, but it's going up like this, so where is that going to stop? Well, never. So it's going to go to a positive infinity. Good job. Now what about my increasing intervals? Where am I increasing? My x and my y? Exactly right. I am starting with 0 and I'm going to a positive infinity. Now what about a decreasing interval? Do I have a decreasing interval? Remember, decreasing interval is where my x's is getting larger, but my y's are getting smaller. Ms. Killen, I don't see that because there's not one. Now what about my y-intercept? Where can I say that my y-intercept is? Now, if we look at this, it's just barely above that origin. So I would say that it's at 0, 1/2, 1/3, right above that origin is what I would say. So there are most of my key features. Now, what I want to do in any notation, I want us to write my domain set. Now, I know we've already wrote my domain in one way. I want us to write it in the other way. So let's do the domain set. So let's put x such that my x's. Now, we said our x's started with negative infinity and went to positive infinity. So what have we learned to express that in set notation? Exactly right. X such that x is an element of all real numbers. We want to make sure that we are understanding those different symbols. Element of all real numbers. Good job. Gary has a piecewise function. Yet another new function we're looking at, but we're going to get to it. That he must answer questions about all the key features. Help him answer the questions. A piecewise function has pieces that make up the whole function. Now, if we remember back when we're looking at this function to make sure it's a function and not a relation, we do that vertical line test. So let's just try that for a minute. Let's make sure it's a true function. Let's see. My vertical line test says if I do a vertical line test, I will only touch my function one time. Now, true, it has different pieces, but when I do that, I'm only touching what's graphed one time. So this is a true function. It's just a weird looking function, but nevertheless it's a function. So now let's look at the questions he's having to ask himself. The graph has no negative intervals. Negative intervals, meaning my y's would be less than 0. On this graph, do you see any of my y's that's graphed less than 0? I don't. So it has no negative intervals. It's true. There is no negative intervals. Good job. All right, next it says this graph has a relative maximum. Now remember we said maximum is the highest point. Do I see a high point? No, I see a minimum, so I do not see a maximum. Now, I want us to be super, super careful reading number 3. When we are reading these test questions, when we're reading these examples of our practice problems, the way the questions ask is how I have to answer it. Sometimes it's going to ask for a no, and sometimes it's going to ask for a yes. So let's look at number 3 and be very careful how we read it. Let's look. The range cannot be written in set notation. That is my key phrase. It cannot be. So let's just look to see the range and see what we can do with the range. my range is all my y values, and it looks like all of my y values are above my 0 or my x-axis. So I could say that y such that all of my y's are greater than or equal to 0. Is that not set notation? So since I can write it in set notation, how would I answer the question? Let's see. The range cannot be written in set notation. Well, that's false. It is extremely false because it can be written. And if it's true, there's my explanation why. So it is very, very important that we are reading the exact questions. Don't answer what you think the question says. Answer exactly what the question is asking. You've always got to make sure you're reading the question correctly. Now, I don't want us to forget important vocabulary such as domain and range, set and interval notation, increasing and decreasing, what that means with my x and y variables, my relative minimum and maximum, and then what that positive and negative interval means, what it happens to be with that y value. I always want to analyze that graph and notice all information because when I'm answering these questions, I want to answer exactly what it's asking me. And remember, piecewise functions are made up of pieces that make a whole function. I'm so glad that you came to work here and learn with us here at MPB. I am Miss Killen. Have a great day.